Hey folks, welcome back to the system design playlist. This is day 03. In the previous lecture, we have discussed about what is latency, and we have also covered API, what is HTTP, what is HTTPS, and we have discussed about client server architecture. We have discussed about so many things like what exactly how the client sends a request and how the server responds back. In this lecture, we are going to discuss about the REST versus GraphQL. This is very important. If I talk about, we will discuss what is REST actually. Let me just make a more thickness. And then we are going to discuss about how it actually works. We are also going to cover some practical examples and what are the benefits of the REST. We are also going to discuss about the drawbacks of the REST. And then there is a difference between REST and GraphQL. So we are going to discuss about the what is actually the GraphQL. We are going to discuss about how it actually works and a few examples of GraphQL. Then there is a 3 core functionality of GraphQL. We are going to deep dive into it. And then we are going to cover the benefits and drawbacks of GraphQL. So let's move to the first topic. Like we have a brief overview. In the brief overview, what do you understand by APIs? APIs are the backbone of the modern application, obviously, acting as a bridge between the client application, as we have discussed in the previous lecture, and the backend servers. So you have a client and you have a backend server, and these act as a communication bridge between them. Among the many API design choices, we have REST and GraphQL, which have emerged as two dominant approaches we are going to discuss about. Both offer powerful ways to retrieve and manipulate. These both offers powerful ways to retrieve and manipulate the data, but they are built on fundamentally different philosophies. They are very, very different. If I talk about a brief overview about the client, so here we have the client, and let's say this is the client. This is the client. What happens is client sends a request to the REST services. So the request is sent one time, and then there is a response generated to it, right? And then again for another thing you need, like you are doing login, so you are sending a request first, then there is a response. Again you want to fetch some email, then again you are sending a request and there is a single response to that. Whereas it is quite different in terms of GraphQL. If I talk about GraphQL, the request is sent once, and there is a collection of things you are requesting. So the GraphQL actually goes to all the servers. It goes to all the services which are required. Like in one stroke you are sending, I need the name of the user, I also need the email of the user, and I also need all the details, like I need the job profile of the user, I need the time he joined, the time he resigned. So I need all the information of the user, for example. And then there is going to be a response. So this is the request, and then you are going to get a response. Okay, let's move ahead. If I talk about the brief overview, then we have the REST. REST is a time-tested architectural style. Structures API around fixed endpoints and HTTP methods. So we have a fixed endpoints. Let's look back to the example. This is a fixed endpoint. Let's say this is 1, 2, and 3. These are the fixed endpoint. Like for one request, there is one response. Again, there is a one request, there is one response. And again, there is a request and there is a response. So there is a fixed endpoint, which is making it intuitive and widely adopted. On the other hand, we have GraphQL. So GraphQL, a newer query language, it is a query language which is developed by Facebook. It takes a more flexible and efficient approach, allowing clients to request exactly the data they need. We don't need to what happens is what data I am requesting, I need only that data. I don't need any additional information that will consume my time and also my resources. So the data that I need within a single request, I am going to request about it. So what is REST? REST has emerged in the early 2000s as a set of architectural principles. It is basically used for designing networked applications. REST is not a protocol. Remember, this is not a protocol or any standard, but it is a set of guiding principles that leverages the existing HTTP protocol to enable communication between the client and the server. If I talk about the REST, at its core, REST is built around resources. Each resource, such as like, what is resource according to you? Resource can be a user, that is clear. Resource can be an order or resource can be a product. Is uniquely identified by a uniform resource locator. And clients interact with these resources using a fixed set of HTTP methods. We have already discussed hypertext transfer protocol methods. At a start, we have like get. So what is get? To retrieve a resource. You want to retrieve something. Let's say I am sending a get request, API users and 123. Here 123 is nothing but the user ID. So I am sending a user ID to fetch the user data. And then we have post. In post, what we do is like we create a new resource. For example, I am sending a post API users to add a new user to the database. And then I have put patch, which means like I need to update the existing resource. I need to update the backend. I need to update the database, anything. And like I am sending a put request API users 123 to update the user details. And then I have delete. Delete removes a resource. Like you want to remove a user, you want to remove a table, you want to remove a particular amount of data. So you want to make modifications, like you want to delete non-usable data. Then you will use delete, and then like let's say this is the user ID. So the user on this ID 123 will get deleted. This will delete that user from the data. Let's move ahead. If I talk about the REST, how it actually works. So let's take an example. Let's say a client needs information about a specific user with ID 123. Okay, so this is actual client. This is my client. And this is the user service. So this is the user service. And the client is sending a request, and then server is generating a response back to the client. So in the request, what I am sending is get API user 123. So here the user ID is actually 123. I am sending this to the server, and server is fetching the information from its core and then generating a response. In the response, if I talk about this, like what it is generating in the response, I am getting the ID of the user, and then I am getting the string, which is first name of the user. This is a first name of the user. Then I am getting second name, which is Smith, and then I am getting email. So this all information I am getting based on the user ID. I have not requested it. Remember, I have not requested that you give me ID or you give me the first name, you give me the second name or the email. It is just providing me based on the ID I am requesting in the get. Okay, let's move ahead. So at its core, REST is built around resources. Each resource, such as the user, order, or product, is uniquely identified by the uniform resource locator, as we have already discussed. And we have discussed like get, post, put, patch, and delete. What happens is REST API typically returns data in the JSON format. That is very important. Always remember this. REST API returns the data in the JSON format. And these uses hypertext transfer protocol status codes to communicate the outcome of the request. Outcome of request is the response we are getting. In the response, it can be like 200 okay, which means a success status, as we have discussed in the previous videos. And it can also create like 201 created, which means the resource is successfully created. And there is a 400 bad request, which means there is a client error. And like I am not providing the fields correctly. Let's say there is a form and I need to fill it, and I am not providing the required field, which is my name. So username, if you are not going to fill it, that will show you an error, right? And then 404 not found, which means the requested resource doesn't exist in the database or either the service you are requesting. And then we have 500 internal server error, which means there is an unexpected server issue. Let's move ahead. Let's talk about the benefits of REST. If I talk about the benefits, simplicity and intuitive design. What does it mean? The resource-based model aligns well with most business domains, making REST intuitive for developers. If I talk about the statelessness, each request contains all the information needed to complete it, making REST scalable across distributed systems. So like what I was doing is I was simply providing the user ID 123, and based on the user ID, it was providing me everything. It was providing me the username, it was providing me the email, it was also providing me like information, first name and last name, as we have seen in the previous example. And then we have cacheability. Hypertext transfer protocols caching mechanism can be leveraged to improve the performance, like we have already discussed in the day one about the caching. So let me brief about it. What caching is, like when I'm requesting for a particular service again and again, I don't need to go to the service actually. So I am going to store into the caching. I don't need to go to that service again and again. I am going to store into the cache memory and then I am going to fetch from it, which is very fast. If I talk about the scalability, REST APIs can be easily scaled. These can be easily scaled, like you can do the scale up and scale out using the concept of load balancers we will discuss in further videos, and content delivery networks. Then we have mature ecosystem with nearly 2 decades of widespread use. REST enjoys robust tooling. It also has good documentation and developers familiarity. Now let's talk about the drawbacks of REST. If you are thinking about what actually the drawbacks of the REST are, so overfetching. Why overfetching? Like I have discussed, you are just sending the user ID 123, but in return you are getting so many things. In return you are getting the name, in return you are also getting the email ID, you are getting the first name, you are getting the last name, blah blah, so many information. REST endpoints often return more data than needed. This is very important. More data than needed, which leads to inefficient network usage. For example, if a mobile app only needs a username, a mobile app needs only a username and you are going to provide only email, but the API response includes additional fields, like it is also providing me address, it is also providing me phone number, metadata. It results in the wasted bandwidth. That is inefficient. Underfetching. If an API doesn't return related data, the client may need to make multiple requests. So underfetching means like either it is doing overfetching, like I am providing only one ID, but it is providing me so many things. Like I am requesting for the username and it is providing, I am requesting for the username, email, and it is providing me address. It is also providing me the phone number, also providing me the metadata, which results in the wastage of resources. And underfetching means like if an API doesn't return related data, I need to make multiple requests. Like what data I need, it is not providing me that. I need to make multiple requests again and again to fetch the requirement and the required information. For example, to get a user detail and their post, the client might have to make a get request with the user ID to fetch the user, and then again there is a get request for post to fetch the user post. So how irritating this is. Like I can't do this again and again. I just need a one stroke and I need all the information. Then if I talk about the drawbacks of REST, these are the further drawbacks. Versioning issues. When the APIs evolve actually, maintaining the backward compatibility becomes difficult. So REST APIs often required versioned URL. We provide the version URL, like you can see version 1, then users, version 2, then users, which add the maintenance overhead, and like rigid response structure. That is a drawback. The server defines how data is returned. The server is going to define, let's say this is a server is going to define how the response should be, and the client must adapt to it, even if they only need a subset of data. Like I was sending an ID, and I need only the user detail, I need only the email, but what I am receiving is, I am receiving so many things. I am getting the username, the first name, I am getting the first name, I am getting the last name, and I am getting the address, which I don't need anything. Like I don't need all these stuffs. I only need the user, I only need the email. So that is another drawback. Okay, let's move to GraphQL. What is GraphQL? For years, REST was the de facto standard for building APIs. It is older than GraphQL. However, like applications grew more complex, REST began to show limitations, especially in scenarios where like client needed fine-grained control over the data. So here, client is going to decide what data I need. You are going to just provide me that, not the stuffs which you are deciding. So not the stuffs which server is deciding, but the stuffs which client need actually. And if I talk about the to address these challenges, Facebook introduces GraphQL in 2015. In 2015, Facebook introduced GraphQL, offering a more flexible and efficient approach to the data retrieval. Let's talk about how actually GraphQL works. Unlike REST, which organizes API around fixed endpoints and hypertext transfer protocol methods, GraphQL is a query language which allows client to request exactly the data they need. The data they need, and nothing more, nothing less. So there is no overfetch, and there is no underfetch. The exact details which I need, I am going to request about it. Note, a single GraphQL endpoint, or we can say GraphQL, replaces multiple REST endpoints. So here, like if the situation of underfetch was there, I was doing multiple requests again and again. Like I need user details, then I am sending ID, and if I need post details, I am sending the post link. So I am sending multiple GET requests, but here that doesn't work. I am just sending the information which I need at a time in single stroke, and I am getting a response about it. So this allows the client to structure their own queries instead of relying on the predefined responses. Let's move ahead. For example, if I talk about the GraphQL client, like if I talk about this GraphQL client, I am going to send the request to the GraphQL server. Okay, and then GraphQL is going to the either user service, or it is going to the profile service, or it is going to another kind of service, which is like we have post service. So this is post service actually. And if I talk about the request, in request, what exactly I am doing is, I am sending the query, I am sending the user ID at the time, and I am sending, like I need the first name, I need the email, then I need the profile, and in the profile I need the URL. In the post, I need the title of the post and the publishing date of the post of the user, right? Whereas in the response, what I am getting is, I am getting the user details, and in the user details, like I am getting first name, which is John, and then I am getting the email, which is John Smith, example.com, and then I am getting the URL. Let's say this is an example URL, and then I am getting the post details, which includes the ID, the title, and the date of publishing. And then again there is another ID, the title, and date of publishing. Now see what actually the difference is. Here you can feel the difference between REST and GraphQL. Here we have the client. Client is sending the bunch of requests at a time to GraphQL server. Then GraphQL server is going to interact with all the services at the backend. Like we have user service, we have profile service, and then we have post service at a time, and all together it is going to generate a response, a combined response, and in the combined response it is going to provide me all the details in JSON format. I hope you got it. Let's move ahead. And then I have explained this, like unlike REST, which organizes APIs around fixed endpoints and HTTP methods, GraphQL is a query language that allows client to request exactly the data they need, nothing more, nothing less. There is no overfetching situation, there is no underfetching situation. You are getting exactly the data which you need, because you are sending a request at a time, the details which you need. So the server is going to provide you the GraphQL server. It is actually the GraphQL server which is going to provide you all the details in one stroke. And note, a single GraphQL endpoint replaces multiple REST endpoints, which allowing clients to structure their own queries instead of relying predefined response. Let's move ahead. Now, how actually the GraphQL works? Let's take an example, like a simple GraphQL schema. For previous example might look like this, like the structure, the architecture we have discussed. So this is how it looks like. We have the type of the user, then we have ID, we have the first name, and then the string, we have the last name as a string, we have the email, then we have profile, then we have the post. And let's say there is a type of profile, and then we have the profile ID and the URL of the profile. If I talk about the type of post, we have post ID, we have the title of the post, we have the publishing date, then we have a string. In the string, we have the content of the string, and then we have the author, which is actually the user who is posting. And then we have the type of query, which includes the user ID and the post, list of post. Let's go ahead. Then finally, we comes on the three core functionality of GraphQL, which is very, very important. GraphQL provides three core functionalities. The first is fetch data, which is actually the queries to fetch the data. And in this, this is similar to GET request in REST, but GraphQL queries allow clients to request specific fields of data. Clients have full control over what they retrieve, as we have discussed earlier, and which avoids unnecessary data fetching. I can request only the data which I need. And if I talk about the example, here is an example of fetching a specific user and post details in a single request. In a single request, I am sending a query, I am sending the user ID, I need the name, I need the email, I need the post. In the post, I need the title and the content, nothing else. And then on the second number, we have mutations. Mutations means you want to modify the data, which is almost equivalent to, which is like post, put, patch, or delete that we have discussed in the REST. These are used to create, update, or delete resources in the API. We call it mutations in GraphQL, but these are called as post, put, patch, or delete in the REST. If I talk about the example, so let's take an example of creating a new post. So we have mutation here. We create a post. This is the syntax. Understand this syntax. This is very important. We have the title, GraphQL versus REST. Then we have the content. In the content, GraphQL solves many of the REST limitations. Then we have published date. Here we provide the published date. And then finally, in a JSON type format, we are providing the ID in the curly braces, and then title, and then the content. Next, in the three core functionality of the GraphQL, we have the subscriptions. Subscriptions are also termed as the real-time updates. Real-time updates means like you have seen Facebook, you have seen Instagram, and you have also seen YouTube. Like what happens on YouTube dashboard is like whenever somebody comes or view counts are increasing or subscriptions are increasing. So that is actually seen in the real time on like live update. If I talk about like unlike REST, which requires polling or WebSockets for real time, like REST requires the WebSockets and polling for the real time updates, but GraphQL subscriptions enable clients to listen for changes and receive updates automatically. We don't need to do it manually like we are doing in the REST using WebSockets. This will be modified automatically, and which is ideal for like chat application, live feeds, stock market updates, and notifications, like notifications regarding comments. If somebody is commenting on your channel, then you are getting it in real time in live update. Then we have example, let's say listening for new posts. So in this you have subscription, then you have new post. In the new post, what you are getting is like title, then you have content, then author, and then name. So these are all the stuffs you are doing. Let's move ahead. If I talk about the GraphQL versus REST, so this is the difference between the GraphQL and REST. Both GraphQL and REST rely on hypertext transfer protocol request and response. So like we have the client server architecture. This is the client and this is the server, right? And this is request and this is response. Both GraphQL and REST rely on the same HTTP. They also use HTTP. They also doing the request and response, but they differ in how they structure and deliver the data. As you have seen, like REST is providing all the things and even so many additional information which I don't need. But GraphQL is providing only those information which I actually need. The REST centers around resources, each identified by a URL, whereas GraphQL centers around schema. That is important. It centers around schema because it is a kind of query language. So it defines the types of the data available. In REST, the API implementer decides which data is included in the response. So it is all about the API implementer, like which data to be included in the response. If a client requests a blog post, the API might also return author details, which I don't need. Why do I need author details if I'm requesting for a blog post? That is a drawback, right? And even if they aren't needed. With GraphQL, the client decides what to fetch. The client has all the authority to decide what to fetch. This makes GraphQL more flexible, but also introduces like challenges. For example, in caching and performance optimization, we have some challenges when we design complex applications and complex systems. If I talk about the benefits of GraphQL, here comes the first one, which is precise data fetching. Clients can request only the fields they need, which reducing the overfetching and underfetching. And if I talk about the single request for multiple resource, related data can be retrieved only in one request, which solves like n+1 query problem. Then we have a strong typing. GraphQL APIs are a schema to define available data, as we have discussed, making them easier to explore and document. Queries are easier to document. And if I talk about the real-time data subscription, GraphQL natively supports real-time data updates through subscriptions, enabling clients to receive automatic notifications whenever data changes on the server. So here we are using the GraphQL server. Which ensures automatic changes. So I don't need to manually go to the, like in REST, we go to the WebSocket and do it all manually. But here I don't need to worry about it. I just need to use the subscription and it will be handled automatically. And then finally, we have API evolution without versioning. New fields can be added without breaking the existing query. Avoid REST style like I was providing version 2, version 1. I don't need that. In one query, I can do that. Now let's talk about the drawbacks of GraphQL. So the first is like complex setup and tooling. Unlike REST, which can be used with the basic hypertext transfer protocol clients, curl browser, GraphQL requires a GraphQL server. This is important. And it also requires a schema, which is nothing but the query language, and also requires the resolver. If I talk about the caching challenge, REST APIs leverage HTTP caching, like example, browser, you have caching, you have content delivery networks. But GraphQL queries use the post request, which makes the caching trickier. And then we have like increased server load. Since client can request arbitrary amount of data, GraphQL APIs must be carefully optimized to prevent performance issues. And if I talk about the security risk, then unoptimized queries, for example, deeply nested requests, you have a query and then again you have so many queries inside, that is nested request, can lead to a costly database scan. Because costly in sense, it will go to this query and then if the data is not in this query, it will go to the nested, then again the nested one, and then again to the nested one, which leads to slow speed. This causes slow speed and also increases the time, hence it is costly, and increasing the risk of denial of service attacks. So this also leads, like if there is someone hacker and that is going to send some kind of request, like it goes and goes, so the server is unable to respond and the server crashes, or there is a downtime for a long period of time. That is not good for us, because that is not good for user experience. So that is a denial of service attack. That is a drawback. And which one should I pick? Which one should I go with? So generally, if I talk about, there is no one size fit all answer. REST remains a great choice for simple APIs, while GraphQL is a powerful for the complex applications with varying data needs. And ultimately, it is not about which is better, which is not better. It depends upon your requirement. It depends upon what kind of system you are building, and it depends upon the needs of the user. If I talk about the REST, use REST if your API is simple and doesn't require flexible queries, and you need caching benefits from hypertext transfer protocols like the browser. You need a standardized, well-established API approach, and you are integrating with third-party services. Your team is already familiar with REST and need faster implementation. So these are all suggestions. That if you are good to go with these, you use REST API. Simple. When to use GraphQL? If you need flexible and efficient data fetching. Flexible in sense, like you are requesting so many things at a time. You are providing all the details at a time in a single stroke. GraphQL performs it, request all the services in the backend, and then in a single stroke, it is generating a good response according to the requirements. It is not overcrowded, or it is not like under details. And like your API serves multiple clients, for example, mobile, web, IoT, then you go with GraphQL because there are different user needs, real-time updates, and these are required. Then you go with the GraphQL subscriptions, as we have discussed earlier, like when to use the GraphQL subscription when you need real-time update. So go with the GraphQL subscription. And if I talk about you want to avoid API versioning issues, then go with GraphQL. Your application requires deeply nested data, then you can go with GraphQL. Can you use both REST and GraphQL? Of course, you can. Absolutely. You can use both the REST and you can use GraphQL at a time. These are not mutually exclusive. and many organizations implement a hybrid approach to get a best of both these. Like GraphQL for client facing applications where there is need of flexibility, performance, dynamic querying is a good to go. And if I talk about the REST for admin interfaces, there is third party integrations as well. Like you have internal microservices where statelessness is required, and then you have caching, so caching using hypertext transfer protocol or browser compatibility and simplicity. These are the benefits, so you can use both REST and GraphQL depending upon the requirement of the user. Thank you guys, this was all about today's lectures. So today we have discussed about what is actually the REST, and we have discussed about the GraphQL, what are the benefits, what are the drawbacks, and what is the difference between REST and GraphQL. We have discussed about all this. In the previous video, I have covered a lot, so you can check the link of the playlist in the description below. Also, if you have any question, any doubt regarding this lecture, you can ask me the questions in the comment section. Do like, share, and subscribe my YouTube channel. We'll see you in the next video.